What up, y'all? I'm back, baby. I got a big ass microphone in front of me today. Let me know if it's crazy distracting. We're trying it out here. So today we're going to talk about leveraging our trading and leveraging our investment strategies. First, we're going to define leverage trading, margin trading, and short selling.
I'll give you these Adidas shorts for $9.99.
Bad jokes to Patrick. Then we're going to show you how to do it on the Kovan testnet using Aave and then SushiSwap or Paraswap or whatever swapping you want to use. And then we're going to code it all up in Python, which is the fun part, right? Because then you can do your algorithmic quantitative investing in DeFi. Now, obviously, none of this is financial advice. I'm showing you how to use some of these strategies. Investing like so can definitely be very risky, but we'll go over some of the pros and cons as we go through. So let's talk about leverage trading. So when we're talking about leverage trading or leveraged investing, it really just means we're borrowing some asset or borrowing some money so we can invest or trade more. It's leverage because we're using more than we initially start with. And this is great because when you pick correctly, you'll profit more, but when you pick wrong, you'll lose more as well. Now, margin trading and short selling are both types of leveraged trading because they both involve borrowing assets. In margin trading, we borrow some cash or some assets so that we can go buy more. And in short selling, we borrow some assets so we can sell that asset in the hopes that the price of that actually goes down. Now, personally, I feel like the main difference really is intent. You call it margin trading when you borrow some cash to buy something that you hope will go up. You call it short selling when you borrow some asset to sell it in the hopes that that goes down. Now, I'm not going to show you an example because there's a ton of people who are way better animators than I am, but I've left a couple links in the description which will show you exactly what the difference is and exactly what these look like if you want to learn more about these different strategies. Now, the question is, well, why would you want to do this? Well, the answer is if you pick right, you'll make a higher profit. If you pick right, you'll make a higher profit. If you pick right, you'll make a higher profit. Higher profit. Wait, hold on, you bonobo ape. Don't you dare hit that button yet. As I said before, this means if you pick wrong, you are going to do substantially worse. And in traditional markets, if you short sell, you actually have the potential for unlimited loss. Luckily, in DeFi, there are some safeguards to protect us, which we'll go into in our example here. But yes, as I said, this is a riskier investment strategy. Proceed with caution. Maybe you might even consider a market neutral strategy, which will give you a little bit more protection here. And is a really fun, nice, advanced strategy too. Link in the description to learn more about market neutral strategies, which do involve short selling. Anyways, let's get into the demo, into the UI. All right, so here we are in the Aave application. It's at testnet.aave.markets. We are in the testnet of Aave. Now, everything that we're gonna do here is gonna work on mainnet as well, but we're gonna use it on their testnet. So Aave is deployed to the Kovan testnet. So we need to first get some Kovan Ethereum. So I have my MetaMask here. You're definitely going to need to start with your MetaMask. A link in the description as well to get a MetaMask account. I got a blank, brand new account called Blank. And we're going to go to the link token contracts to get the latest Kovan faucet, which is right here. Link in the description will bring you to this page as well. Let's go to this Kovan faucet, grab my address, paste it in here. Kovan, I'm not a robot. Send me 0.1 ETH. All right, looks like it was successful. Let's look at my wallet. And great, we have 0.1 testnet Kovan Ethereum now. We are now back here. In order for us to actually short sell or margin trade, the first thing that we're going to need to do is actually deposit some collateral. We need to deposit some collateral in order to borrow. This way, if we never repay back the loan that we took out or the amount that we borrowed, Aave will just go ahead and take the collateral that we put in here, right? It'll do what's called a liquidation call. And that's why this is actually a little bit safer than short selling in traditional markets, because if your collateral is less than how much you have borrowed, you'll just immediately get liquidated. But you still lose a bunch of money, so like, don't get liquidated. So what we want to do now is we're going to scroll to Ethereum. We're going to connect our wallet here. We're going to move to Kovan Test Network, browser here, and we're going to go to this deposit piece. So it already shows our balance here. We have 0.2 Kovan ETH. Let's deposit 0.1. We're going to hit deposit. MetaMask is going to pop up, confirm. But once this goes through, this means that we have it deposited. And we go to our dashboard, we can see we have some ETH here, 0.1 ETH. It's got some APY. This is kind of like that percentage return that we're going to get back for depositing into Aave. And yes, we can use it as collateral here. We have this marked as yes here. So that's exactly what we're going to do. And it says nothing borrowed yet. We can go ahead and hit this borrow now button. And we're going to get brought to the borrow screen. And we're going to choose which asset we want to borrow. Now, whenever we borrow one of these, there are these APYs, right? This is the percentage that over the course of a year that we're going to have to pay in order to actually borrow this asset. The stable one means it'll always be 4, or variable means it actually changes depending on kind of how much liquidity the protocol has. You can kind of pick which one you want to do. Stable is you're always going to be at 4%. Variable is going to be a little bit riskier, but you might get a lower fee. So we're actually going to borrow some DAI, right? Because DAI is a stable coin. It's worth $1. In a way, you could call this taking out on margin because we're taking out DAI to borrow. And another way, we could say we're shorting DAI, which is kind of funny to think about. You get to choose how much you want to borrow here. And you'll see this thing called health factor. I'm going to zoom in a little bit. This thing called health factor here as we scroll this thing. So this health factor is how close to being liquidated you are. Remember how I said you can get liquidated? This health factor represents how close we are to getting liquidated. This means how close we are to Aave saying, you know what, F you, we're taking your funds. If it goes below 1 at any time, somebody can liquidate you and take a lot of that deposit that we put in. There's some math behind actually what the health factor actually is. You can head over to the Aave documentation, which I will leave a link in the description to kind of read more about the health factor. So we're going to borrow 29 DAI. We're borrowing basically $30. Gonna hit continue. I'm gonna do a variable, zoom back out, continue. We're gonna borrow, MetaMask pops up, confirm, transaction is pending, and we're gonna go to the dashboard. And now we can see kind of our new balance here, right? We can see the 0.1 ETH deposited and 29 DAI. And we can see our health factor up here. You can even click this little button saying, hey, it represents how close you are to being liquidated. We can see the value here. Our ETH is worth like $200. Our DAI is worth $30. So we're good. We're pretty healthy here. This is basically the definition of margin, right? We could take this DAI and we can go out and use it to buy other things. So all we really need to do now is sell this DAI for some other asset, and we've essentially shorted DAI. So all we need to do is swap it. So if I look in my wallet now, if I go to assets here, let's add token. Now, if I grab this wallet address, let's go to the Coven Etherscan. All right, let's go here. Boom. We can see here that I've got some interest-bearing, some interest in my Ethereum, some debt, and then our DAI here, right? So what we can do is we can grab this contract address. Let's connect here, add token here. We'll paste it in. And now we can see the DAI that we have in our MetaMask. So we see the ETH that we currently have in our MetaMask, the DAI that we currently have in our MetaMask. We see the ETH deposited into Aave. So what I can do then is I can take this DAI and then I can go to like SushiSwap or something. Go to Uniswap. SushiSwap doesn't really matter. It doesn't really work on the testnet here so much. This is essentially all you need to do to short the asset then. You just go to some swapper and swap it, and that's it. And that's how you short it. You'll see you'll still have to repay it here at some point. So you'll always be getting charged here, this amount. Yeah, if your health factor goes below 1, you're gonna get liquidated. So it's really, really important to keep an eye on this stuff. So now that we learned how to do it through the UI, let's do it programmatically in Python, right? Doing it programmatically in Python is going to allow us to have way more creativity and flexibility, do some algorithmic DeFi stuff, which is really cool, do whatever you wanna do. And it'll give you a lot more experience in working with these protocols from a solidity level as well. All right, welcome to the behemoth of my repo that is this DeFi Pi mix. All of the code that we're gonna be working with is available here on this DeFi Pi mix. We're gonna have a link in the description. I even said, this looks like fun. Link in the description to everything here so that you can take it, run with it, and do whatever you want with it. So this is gonna be a little bit more advanced. We're working with both some advanced Brownie features here, and this is some advanced DeFi features. So don't be intimidated, don't worry, it's okay. Ask a ton of questions and have fun. All right, so we're just gonna go ahead and run our short selling script on the mainnet fork. So we're simulating running this short selling basically on the mainnet chain. So we're gonna do Brownie, run scripts, swap, short sell.py, network, mainnet, fork. And we're gonna hit enter. I'm gonna walk you through exactly what's going on in this script. So first, we go ahead and fork our mainnet here. So now we're running our own mainnet, but in a local environment, so we can do everything much faster. But so here's what happened. Ethereum balance right now is this right here, which is actually going to be 0.1 ETH. And you might be saying, oh, well, why is it WETH? Well, actually, whenever you deposit ETH, whenever you trade ETH and with like Uniswap or something like that, you actually send it through what's called the WETH gateway and actually converts it to wrapped Ethereum. So it turns it from Ethereum to like an ERC20 token version of Ethereum. But don't worry about that too much. Just know that this is our starting Ethereum balance. This is our starting DAI balance. So first we need to approve our WETH as same thing as Uniswap to actually send it into the Aave smart contract. Excuse me. Once we have it approved, then we go ahead and deposit it into the Aave smart contract. Once it's deposited, we take a little bit of inventory real quick. Okay, great. We have 0.1 ETH deposited or WETH deposited. We have nothing borrowed, and here's how much we can currently borrow. So we're going to go ahead and borrow it. So first, you do need to grab the DAI ETH exchange rate to figure out how much you can actually borrow. And we're going to go ahead and borrow 161 DAI. So we go ahead and we borrow it, and great. Now we just borrow 161 DAI. Then we're going to go ahead and swap this DAI for more ETH on the SushiSwap or Uniswap or whatever swapper that you please. This is essentially going to be short selling or buying on margin, right? So we're going to approve selling it. Once we approve it, we grab the price because you need an oracle whenever you call one of these swapping functions. And then we end it out with saying, here's our ending wrapped ETH balance and our ending DAI balance, which it's like 99 cents, right? Because we swapped all of it for wrapped Ethereum. And so this is how much we have in our wallet. And then we have an additional 0.1 placed in Aave. So we've essentially doubled up. So we haven't quite doubled up on the amount of WETH that we have. We've gotten more WETH or more Ethereum by leveraging the existing Ethereum that we currently have. So let's go ahead and actually code this and so you can see exactly how this is built. Again, if you're just git cloning this, you can just kind of follow the README or do exactly what I just did and kind of change some of the stuff in here. I gotta be honest, this repo is definitely a work in progress. I'm planning on adding more things to it. Right now it's kind of a conglomerate of a mess. So if there's an issue, definitely 100% go to this repo here. Definitely go to this repo, leave an issue, ask a question, fork it, do whatever you want. And that way I can get back to you and help you guys out. So if there's any issues, literally go to issues, make an issue, I'll see it. But here we go. So we want to create this shortsell.py script. I'm just going to go ahead. I'm going to create a new file for this demo, and we're going to call it shortingdemo.py. So this is where we're going to code everything that we need to actually, do a short sell. So let's go ahead and just kind of take some inventory of what we're trying to do, right? So what we want to do is we want to deposit collateral into Aave. Then we want to use the collateral to borrow DAI. And then we want to sell the DAI for more ETH. So actually we're gonna, instead of collateral, we're just gonna say ETH to make it easy. And ETH/WETH, ETH/WETH, /WETH, ETH/WETH, right? Because WETH is that ERC20 version of Ethereum. So how do we actually do this? Well, let's just go ahead and get started with a main function here, right? And so we are actually going to be testing this on a forked mainnet, right? So we're going to simulate actually running this on mainnet. And you do need a couple of environment variables to do this. If you're unfamiliar with setting environment variables, don't worry about it. You can just set them in this .env folder. So you're going to need your Web3 Infura project ID, which you can go ahead. You can just go to infura.io. I've done a couple videos on getting an Infura key. Just sign up for Infura. You can get an Infura key super quick, super easy. You'll need your private key, which again, you can grab from MetaMask. So you go to MetaMask, hit here, account details, export private key, and you'll add your password, export your private key. Just remember to append a 0x at the beginning of your private key, then pop it in here. And then you don't need Etherscan token. But okay, once you have those, there's one other thing you'll need to do. So you'll need to run Brownie networks list. And we can look into our Brownie networks because we want to run on a mainnet fork. And if you don't have a development environment that looks like this, what we're going to want to do is we're going to want to add a mainnet fork development environment. So the way that we can do this is we're going to run Brownie networks add development. We'll call it mainnet fork. We'll say command is going to be the Ganache CLI, and this should all be the README. Host is going to equal to HTTP 127.0.0.1 or localhost. fork equals, and this is where we actually put a fork URL. You can use Infura. However, I've had a lot more success actually with, you can actually, same thing as Infura. You can go ahead and get started for free. You'll get your URL for mainnet. And then you just come back here, you'll add that in here. So it'll be like HTTPS or HTTP, ethalchemy.com/mainnet dot, whatever it is or whatever. And then we'll just do chain ID, or chain ID equals 1. And then you can just add that. And then you'll know you've done it right if you can run Brownie networks list. At the bottom, you'll see this mainnet fork. It should be under your development. We don't want it under Ethereum. If you want to do it on Ethereum, you can too, but we definitely want to make sure it's under this mainnet fork. Once we're all set up there, then we can actually start doing some shorting stuff. Okay, cool. Let's do it. So we're going to be making a lot of transactions, right? So whenever we make transactions, we're going to want to be pulling in our account, right? So always we're going to do account equals get account. I actually have a script called get account that helps me out, called from scripts.helpful scripts import get account. Then the 2 ERC20 tokens that we're interacting with are going to be DAI and wrapped Ethereum. So we need those 2 addresses. So we're going to do weth address equals, I pretty much always put them in some type of mapping like this, or in the config file here, because they can change across different networks, right? Like the weth token is a different address on Kovan than it is on mainnet fork. And if you want to test on Kovan or Polygon or like Binance Smart Chain or whatever you want to do, you want to be able to flip between them. So I always put them in this config. You can flip back here and see what that looks like. But then once it's in the config, we can just pull it from the config based on the network. So we're going to say config networks network.show active. And this returns like whatever network that we're on. And we grab that from Brownie. So from Brownie, import network. We also need config in here because we need to work with that config. And then in here, we're going to add the weth token, right? Because this is where we're pulling from. And we're going to do the same thing for DAI address. So the DAI ERC20, we're going to literally just copy paste this whole thing. We're going to do DAI token. Great. You might see in my script Aave DAI token, it's the same thing. Now, when we actually interact with Aave and we deposit our Ethereum, like I said, it actually gets swapped over to wrapped Ethereum. So we could do it. So we could code this in a way that we use what's called the weth gateway through Aave, but we're actually just going to go ahead and get some wrapped Ethereum ourselves using the weth contract. So I'm just going to go ahead and do get weth, and I'm going to create a function called get weth. Now, I've already created this. So I'm actually not going to recreate it. I put it in a get weth script. So I'm going to do from scripts dot get weth import get weth, and then we can look at that real quick in this get weth script. What we're going to be doing is we're literally just working with this weth script, and this is how we interact with it, and we call this deposit function on the weth contract. So we deposit some of our Ethereum. That's we deposit it by sending some value, and in return, it's going to mint us some wrapped Ethereum. So we're sending it Ethereum, we get minted wrapped Ethereum. Hopefully that makes sense. So we're going to use this get weth function right here, and we have to pass an account. So once we have some weth, now we're going to go ahead again. We're just going to follow this path here, right? So now that we have some weth. Okay, great. Now that we've got some weth, we can now deposit this weth into Aave, right? The exact same way we did it in here. We went to deposit, we hit the deposit button, we deposit our Ethereum, which got converted to wrapped Ethereum. So we're going to do this by first getting the lending pool. Now I have another video on borrowing and lending with Aave. A link to that is going to be in the description if you want to get a little bit more in depth there. So I am going to kind of speed through this section as well. Definitely go check out that video. I go much more in depth than I'm going to go through here. So I'm just going to say Aave stuff here, right? So the first thing we're going to do is we're going to get the lending pool. This is the contract that actually allows us to borrow and lend in. And I have a whole bunch of scripts in my Aave section that already get this lending pool. So I'm just going to go ahead and do from scripts.aave, Aave borrow, import get lending pool, get borrowable data and borrow. So we're going to first get the lending pool. This is the contract. This is basically the main Aave contract that we want to interact with. Then we're going to approve sending it some wrapped Ethereum for DAI. So we're going to do approve ERC20. We're going to put some amount in here. Let's just do amount equals, let's do 0.1. So we can do web 3.2 way, 0.1 ether. So then we also have to import web3. So we'll do from web3, import web3. There needs to be a comma here. So we're going to do an amount here. We're going to do 0.1 WETH. We're going to approve the lending pool .address to actually use our WETH. So we're going to give approval to the lending pool .address. We obviously have to say it's approved on the WETH address and then our account here. And now that it's approved, we can go ahead and deposit it. So we're going to go ahead and do a little print here, print depositing, and we're going to call the deposit function on this lending pool. Again, I go into this a little bit more in depth in my other video, but we can just do lending pool .deposit. And we're going to do the WETH address, amount, account, account.address. And then there's no referral code, so we'll just do a 0 there. We don't have to do this from account, unlike the approve and stuff, because I've already defined like this from account in this approve function. But we're going to go ahead and deposit it, and then we're just going to print out deposited. And then we have to, we have to make sure we wait for the transaction to finish. Otherwise, Brownie gets a little bit mad. So let's get some borrowable data, right? So let's find out how much borrowable ETH, and then total debt we have. Total debt ETH is going to equal to get borrowable data. This is a function, again, that I've already written. Go check my other video to learn about it with lending pool and account. So now let's go ahead and borrow some DAI, right? So now we're going to borrow some DAI. And the way that we're going to do this is first, we need to get the conversion rate between Ethereum and DAI, right? So we're going to need to get the DAI ETH price. And we can do this with get asset price, which is a function that, again, I have already coded, which comes from our Chainlink scripts. So we have from scripts.chainlink.chainlink, import get asset price. We're going to use this to figure out how much we can actually borrow. So we're going to call amount DAI to borrow. It's going to be equal, and then we're going to do a little bit of math here. The reciprocal, 1 over the DAI ETH price times the borrowable ETH times 0.95. Now this DAI ETH price means every 1 DAI equals this many ETH, right? So we actually want it the other way around. We want every 1 ETH equals X DAI, right? So we're just going to take the inverse of it so that everything's kind of in terms of ETH here. And then we multiply it by the borrow of ETH. And we also do a little bit less than 100% just so that, again, that we're safe. We're going to be below that threshold. We're going to stay healthy. And this is how we're deciding how much we want to borrow. So then I also have a little borrow function here. I called it borrow ERC20, which we're going to be from the lending pool. We're going to borrow that amount DAI to borrow. We're going to use our account. The ERC20 address equals the DAI address, right? We're borrowing the DAI, and that's it. And this function also already does that tx.wait here, so we don't have to do it again. Now, here's where we get spicy. Now, we short sell / buy on margin, right? After this means we got some borrowed DAI, right? We have more money than we actually have. We have some debt now. We owe some DAI. We can go ahead and take this DAI and go buy some stuff. So we actually need to swap it with some sort of swapper, right? We need to use an interface of some sort, but we need to actually interact with these contracts a little bit. Now, the contracts for Uniswap and SushiSwap might be a little bit daunting if you're a little bit new here, but I'm going to give you the skinny here, right? I'm going to give you the juice, if you will. So I've already written a little bit of a swap function here, right here, swap, and it's kind of a mess, but so be it. The way that it works is if we look at their Uniswap router, right? When you actually go to Uniswap or SushiSwap, and you do like one and one, whatever, and like the big swap button comes up. What you're actually doing is calling one of these swap exact tokens for tokens, swap exact tokens swap tokens for exact tokens, swap exact ETH for tokens. You're calling one of these swap functions. Since we already swapped our Ethereum to wrapped Ethereum, we're going to be doing swap exact tokens for tokens, right? So we're going to say, hey, we have, this much DAI, give us at least this much of another asset back, right? So this is the function we're going to call. And if we can even look in our config here, in our Brownie config, I already have a couple of these addresses in here in this mainnet fork. I have the SushiSwap router and the Uniswap router, right? Like if I take this, I go to if I go to Etherscan, pop it in the search bar, right? We're going to come to the SushiSwap router, and we can see if we go to the contract, we go to write contract, you'll see all these exact functions here. Swap ETH, swap exact, blah, 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 blah. So this is the main contract that we're actually working with to do our swapping. And it's the exact same thing on Uniswap, which is really nice. So let's look at this swapping function real quick, because we do need to understand it. Basically, again, this swap is just us selling the DAI, right? And so here's how you actually do it in Uniswap or SushiSwap. So first you need a path, which is kind of this weird, like kind of pool jumping path, right? So we're basically saying, hey, we're going to go from DAI to WETH, right? There's a DAI WETH pool that we can do. If there wasn't a DAI WETH pool, maybe we'd have to jump a couple of different pools. But for us, this is all we really have to do. It's just one pool. There's already a pool for it. Great. Now, interestingly enough, whenever you call one of these functions, you actually need an oracle of some kind. So you need something like Chainlink to get the price of an asset to actually call these swap functions. So again, since we already have the Chainlink price feeds, which work perfectly, we're just going to go ahead and do that. This get asset price again, which we don't need this again, but we're calling it anyways. And then this is interesting. We actually have to put in like the amount out min. And this is actually really important. This is why the oracles are so crucial here. Somebody could actually front run our swap and buy a whole bunch of WETH, right? So we're actually, if we go to our shorty demo, we're going to sell the DAI from our WETH. Somebody could see one of our big transactions come in, buy up all the WETH and sell it back to us, and they make a profit, right? So what we want to do is we want to have this amount out minimum that we say, hey, if the transaction has less than this, F it, screw it. We don't want to do it, right? And we're just, to be safe, we're doing 90%. If worst case scenario, this would mean we're having 10% slippage. That means we're going to get a 10% worse price than we should. So ideally you'd want to do like 98 or something like that, but just for the demo, we're just doing 90 because, whatever. So amount out min, we're saying the minimum amount that we want back is going to be based off the price of wrapped Ethereum or Ethereum. Then we have to give it an expiry time. This is a fun little way to get like the current timestamp. So you say based off the chain, you get the current block number, and then you just grab that timestamp, and then we'll just add 120 to give it 120 seconds later. Then we grab the router v2, and we can interact with it because we have the interface, which compiles down to the ABI. Remember, guys, whenever you interact with a contract, you always need an ABI and an address. And the interface compiles down to the ABI. So we have the ABI, we have the address, which again is in our Brownie config. And then we call this function, swap exact tokens for tokens, which we pass in the amount we want to swap, the amount we want back, the minimum amount we want back, the pool jumping path, which account we're going to swap for, the timestamp, and then from account. And then we're going to wait for that transaction to confirm. So a lot of stuff there. But now that we know actually how to swap, we can go ahead and just call this swap function. Well, we approve, and then we can call the swap function. So let's approve first. We'll say tx approve equals, we'll use this approve ERC20 again. We're going to approve this amount to DAI that we borrowed, right? Amount DAI to borrow is how much we borrowed. So we're going to approve that. We're going to use the SushiSwap v2 router, which we need to get that address. So let's just put that in the top. We'll call it SushiSwap v2 router 02. And again, we can grab this from our config networks, network.show active. And this is, let's even just open it back up. SushiSwap v2, right. So it's this one for SushiSwap, this one for Uniswap, whichever one tickles your fancy. Let's spell network right. And great. So now we have this. We're going to approve. We're going to allow the SushiSwap contract to you to spend our tokens. We're going to spend the DAI, and it's going to be with our account. We're going to wait for this to go through. And then we're going to swap it. So we're just going to call this that swap function that I already have imported. Or do I have this imported? No, I don't. From scripts.swap, import swap. So just call the swap. So we're going to swap DAI for WETH, and we're going to swap pretty much everything that we have. Now, you're going to run into some errors if you actually just swap everything. So normally I'll do like a little bit less just so that I don't run into these errors. It's kind of annoying, but such is life. So two-way Ether. So what we're going to do here is we're saying, hey, put everything back except one DAI, right? So this means except for one DAI. I know this says Ether, but it's just converting to the units of Ether, which, you know, it's just one DAI. We're going to swap all of our DAI -1 with our account. We're going to pass in the price feed address, which we actually need to get. So we do need that price feed again. In the config, it's DAI at the price feed. Great. Price feed address. And then the SushiSwap, the swapper that we're actually going to do it on. And then does our swap function return? The swap function already calls wait. So great, we don't even have to wait. Oh my goodness. Then let's just do a quick print. I'm actually just going to copy paste here. But we're going to print ending WETH balance is, oh, we got to import interface from Brownie. Ending WETH balance and ending DAI balance, right? So we're going to get our ending WETH balance and ending DAI balance. All right, moment of truth. Let's see if this works. Sorry, scripts.swap.swap, excuse me. We actually need to do this before we even approve, excuse me here. Right, amount DAI to borrow. This needs to be in WEI for approve ERC20, I believe. So we need to convert it to WEI first, then we need to approve it. Then we're going to wait for the approval to go through. Then we're going to swap it. Boom. Moment of truth. Let's do it. First thing we're going to do is we're going to get our wrapped Ethereum, our ERC20 version of ETH. Perfect. Then we're going to approve it to send it to DAI, deposit in DAI. Great. This transaction deposited there. We'll get a little bit of deposit stats here. Great. 0.1 worth of ETH deposited. We have the DAI ETH price feed, so we can go ahead and convert it and figure out how much we want to borrow back. And we can go ahead and figure out the minimum that we need to swap so we don't get front run by evil people. Great, we've borrowed about 158 DAI. And now we've approved to swap it with the SushiSwap swapper. We've got this DAI ETH price, which we can use to protect ourselves from front runners. And then we go ahead and swap it, and we did it. And now we can see our ending WETH balance, right? So if we go ahead and grab this, paste it in here, paste 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have, 0.1 WETH swapped, and then we have this much DAI, right? Because, and this should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, right? So we have exactly 1 DAI because we subtracted 1 DAI here just to make sure everything went through correctly. And then additionally, we have 0.1 ETH. Is that right? Yeah, it is right, because our get WETH actually got us 1 whole WETH. So this number, so we actually got about 0.07 in additional WETH, which is awesome, right? So we have 0.1 in Aave, and then we got 0.07 in additional WETH. So I probably should have made this give us 0.1 WETH just so that it looked clear. But essentially, this is exactly how you short sell. This is how you buy on margin programmatically with Python. Let me know what you guys thought in the comments section per usual. Any thoughts, comments, questions, definitely don't be afraid to ask. Jump into the Chainlink Discord, leave an issue on the repo, ask a Stack Overflow question, join the community. That is how you will learn the quickest. And also be sure to subscribe, because at 10,000 subs, we're doing a little bit of a tattoo reveal. And have fun chasing bananas, guys.